In our last video, we looked at solving multi-step inequalities, which should have been a review. That's something you would have done in your Algebra 1 classes. Today, we are going to learn about compound inequalities. Oops. Gotta spell it right. So compound inequalities is what we'll look at today. This may be new. This may be something that you didn't do in your Algebra 1 classes. All right, compound inequalities. What are they? Compound inequalities are two inequalities graphed together on the same number line. So we have a compound inequality anytime we are asked to graph two inequalities together on the same number line. Now, what you need to know is that there are two types of these compound inequalities. The first type are AND inequalities. And then the second type are the OR inequalities. So AND and OR, those are our two types of compound inequalities. All right, so let's start with AND inequalities. Before we look at an AND inequality, I want you to think for just a moment about the word AND. If I were to tell you, and don't take me at my word on this, this is just an example that I'm using. If I were to tell you that next week we wouldn't have any assignments and I was going to give everybody a free grade of 100. So next week we won't have any assignments and everybody will get a free grade of 100. Then in order for you to feel like I told you the truth, then think about what I'm going to have to do. For you to feel like I told you the truth, I'm going to have to do both of those things because I said and. And implies that we're going to do both. I'm not going to give you any assignments, and I'm going to give you a free 100 grade. For that to be a true statement, I have to do both of those things. Now, the reason that I'm bringing that up is because it kind of applies to what we're going to do here with inequalities. So here is an example of an AND inequality. I could say x is greater than 1, and x is less than 4. So when I look at this AND inequality, and I'm trying to figure out what x needs to be, I need to keep in mind that this thing spells out two things that have to be true for that x. X has to be a number that's bigger than 1, and x has to be a number that's less than 4. So whatever x is, he has to meet both of those requirements. He has to be a number bigger than 1, and he has to be a number that's less than 4. So I want you to think about the numbers that would do that. So let's picture a number line here. We'll put 0 on it for reference. 1 and 4 would both be to the right of that. So the solutions for this inequality, the things that x can be, are the numbers on the number line that are greater than 1 and less than 4. So that would include 2. 2 is greater than 1 and 2 is less than 4. It does both things. 3 would also work. 3 is greater than 1 and 3 is less than 4. 3.5. 3.5 is greater than 1 and 3.5 is less than 4. If I went over here and I looked at a number like 5, 5 is greater than 1. That's true. But 5 is not less than 4. So 5 is greater than 1 and 5 is less than 4 would be a false statement. So 5 is not a solution. If I were to pick 0, 0 is greater than 1 is not true. 0 is less than 4 is. So 0 won't work in this and inequality because it doesn't meet both of the requirements. So here's the deal with a problem like this. The numbers that are greater than 1 and less than 4 are going to be those numbers that are in between 1 and 4. Is 1 included in this? No, because it says x has to be greater than 1. It doesn't say x can be equal to 1. So that's going to get an open circle. X is less than 4. Can x be 4? No, because it doesn't say that x can be equal to 4. So that's going to get an open circle. But then the numbers that meet the requirements of this and inequality are going to be all of these in the middle. So all of the numbers that I just shaded in are the numbers that are greater than 1, so the numbers that are greater than 1, and also less than 4. They meet both of the requirements. So in an and inequality, the numbers that you're looking for have to meet both requirements. And they are going to be the numbers that are trapped in between those two values that we're seeing. Now, I like to refer to this graph. When you graph and inequalities, you're going to hear me refer to this as a car bumper. The two circles would be like the headlights on my car, and then this little shaded part would be the bumper. So when you graph and inequalities, that car bumper is what you're going to see. Now, the next thing I want us to do before we leave this behind is to think about the interval for this. Earlier in the week, we started talking about these intervals. Now, this time instead of array, so let me take you back to your geometry a little bit. This time instead of array, if I look at what I've drawn on my number line, what I see is a line segment. It has an endpoint over here and an endpoint over here. It doesn't have an arrow on it like the graphs we were seeing earlier in the week. So when I write my interval, remember it's those two ends of that graph that I'm concerned about. So one end is at 1 and one end is at 4. So when I go to write my interval, those are going to be my two values, because remember, an interval always requires two values. I work left to right, smallest to largest, so I'm going to do 1, 4. And then I need to add my parentheses or my brackets. So is 1 included? It's an open circle, so no, so that's going to be parentheses. Is 4 included? No, it's an open circle, so that's going to be parentheses. So what my interval is saying is that x can be anything from 1 up to 4. And it doesn't include 1, doesn't include 4. So any number from 1 up to 4, not including those numbers 1 and 4. So for and, both parts have to be true. We have to meet both requirements. Graph will be this car bumper type of shape. And then here's my interval. All right, now let's look at or inequalities. Same thing here. I want you to think about that word or. If I said next week we won't have any assignments, or I'll give you a 100 free grade, then in order for that statement to be true, I only have to do one or the other. Or is more forgiving. So as long as I do one of the two, then I am good to go. So now to put this in a math context. Let's say that I have x is greater than 3, or x is less than 1. So I'm going to get my number line ready. 0, 1, and then 3. Now, this time I've got these two connected with or. So whatever x is, he only has to do one or the other. He's either got to be greater than 3 or he has to be less than 1. All right, so let's think about numbers that are greater than 3. That would be an open circle, and then it would be all of the numbers to the right of that. And I would have to fill in that arrow. So 4 would work in this statement because 4 is greater than 3 or 4 is less than 1. It's greater than 3. It did one of the two things, so I'm good to go. X less than 1. That's an open circle on 1. And then I would shade to the left and fill in this arrow. All of these numbers would work. So if I were to pick 0, 0 is not greater than 3. But that's okay because this says or. 0 is less than 1. So he does one of those two things. So for or inequalities, they're more forgiving. The numbers that fit at least one part of it are solutions. For and, he's more picky. The numbers that you select have to meet both parts of it. So this is what your graph for or statements will generally look like. And I like to talk about this as being airplane wings. So because I can picture those two arrows being like the wings on an airplane. Now, let's talk about the interval this time. When you look at this one, and you think about what I've taught you so far about intervals, I told you that for intervals, you needed two values. And what you'll notice here is I've got two rays. I've got this ray, which is negative infinity to 1. So I've got this part of it. And then I've got this ray, which is 3 to infinity. I've got two rays, two shaded areas on this thing. So when I write my interval, I'm going to have to write both of those. So for this part over here, I'll do it in blue. For this part over here, my two values are negative infinity to 1. Remember, work left to right, smallest to largest, parentheses and parentheses, because neither one of those numbers is included. Now I'll switch to my green, and I'm going to describe this ray, 3, comma, infinity. And that again would be parentheses and parentheses. Now, you have your two rays described. You've written the interval for each one. Your final step is to put a U in between those, and that U stands for union. What that means is the interval is both of those things together. So to kind of summarize, when you see an and inequality, x's that you pick have to work in both parts. You'll get a graph that looks like a car bumper. See if I can go back to that. So your x's have to work in both parts. You get a graph that looks like a car bumper and this single little interval that describes that line segment that you've shaded in. And then, with our OR inequalities, we get a graph that looks like airplane wings, so these two rays. And when we write the intervals, we have to write one interval for each wing. And then the interval is the union of those two wings. All right, so that's the basics. Now, what we are going to do is take this idea of a compound inequality and put it with what you've been doing through the rest of this week. So we are going to be solving these compound inequalities. And what we're working on right now kind of builds. So, you have to understand inequalities to get compound. You'll have to understand compound to get what happens next. So if any of this is not making sense, get in touch with me and let me know. All right, so solving compound inequalities. Here's what we're talking about. All right, first thing I want to look at with this example is that this is an OR problem. So my y values are going to have to do either one thing or the other. I should expect airplane wings when I get this all graphed out. So what we're going to do here is you're going to take the first problem and solve it, second problem and solve it, and then we'll do our graphing and our interval notation. So we have negative 3y plus 8 is less than or equal to a negative 7. If we're going to solve that for y, the first thing we're going to have to do is solve it for negative 3y. So we're going to do minus 8 and minus 8. That gives us negative 3y is less than or equal to a negative 15. And then we're going to divide by negative 3 and divide by negative 3. Because we are dividing by a negative, we're going to remember that that makes our inequality sign flip. So we're going to get y is greater than or equal to 5. Now, we go to our second inequality. 10y minus 3 is less than or equal to a negative 33. To solve for y, the first thing you're going to do is solve for 10y. So to do that, we're going to add 3, add 3. We get 10y less than or equal to a negative 30. And then to get y by itself, we divide by 10, divide by 10. We are not dividing by a negative, so we don't flip that sign. And we get y is less than or equal to a negative 3. And I'm going to carry that word or down here. So here is my solution. Y in this problem can either be a number that's greater than or equal to 5, like 6 or 7 or 8, or y can be a number that is less than or equal to a negative 3, like negative 4 or negative 5 or negative 6. It can be either, because this thing says or. So now, let's put this on a number line. Positive 5 is over here to the right, negative 3 is over here to the left, and what I'm going to do is graph that first inequality. Y is greater than or equal to 5. I know that that will require a filled-in circle and then shading to the right. Then we'll do y is less than or equal to a negative 3. That will require filled-in circle and shading going to the left. So notice, or statement, I have my airplane wings. Now, when I do my interval, there are two rays here that I've graphed. So I'm going to have to do two values for each ray. So on this ray, it's negative infinity, negative 3. And on this ray, it's 5 and infinity. Infinity always gets parentheses. X can be negative 3, or Y can be negative 3, so that's going to be a bracket. Y can be positive 5, so that's going to be a bracket. And then infinity. Put your U in the middle because it's both of those things together. The union of those two intervals is our solution. So there's what that problem looks like. So notice, you're using your solving skills that we worked on yesterday. You're using your number line and interval skills that we learned earlier in the week. And now we're adding this and or element to this. So for this example, we have 2w plus 1 is less than or equal to 11, and 1 minus 5w is less than 41. So this is an and statement. An and statement. So let's solve each part. Let's start with 2w plus 1 is less than or equal to 11. We're going to do minus 1 on each side to get 2w alone. That gives us 2w is less than or equal to 10. Then we're going to divide both sides by 2. We don't flip our inequality sign because we're divided by a positive. So we find out that one of the things that has to be true is that our value for w has to be a number that's less than or equal to 5. All right, over to the other one. To solve for w, we first need to get negative 5w alone. So we'll subtract 1 on both sides to make that happen. We get negative 5w is less than 40. We divide both sides by negative 5. Because we are dividing by a negative, we do flip the inequality. And it's going to be w is greater than negative 8. And let's not forget that this was an and. So this solution is telling me that my numbers for w have to be two things. They have to be less than or equal to 5, and at the same time, they have to be bigger than a negative 8. So if I think in terms of a number line, w less than or equal to 5 means that I would have a filled-in circle, and my shading would go to the left. W greater than negative 8 means that I would have an open circle on negative 8 with my shading going to the right. So we can see how those are going to bump into each other. So to account for the fact that this was and, I stay in between those two. There are the numbers. What I just shaded are the numbers that do both of these things, that stay under 5 and that stay above negative 8. So that would be my solution. There is my car bumper. And what I like about these is the interval is really easy to do because I just have this one section, this one line segment. My two values that describe this interval are negative 8 and positive 5. Negative 8 will get parentheses because he's open, he's not included. 5 will get a bracket because he's closed, he is included. So w can be any number between negative 8 and 5, including 5, but not including that negative 8. Now, I want to talk about one more thing with these and statements before we leave it, because it relates to the next example that I'm going to do. And this only applies to and. So please make sure you hear that this only applies to and. When you have an and statement, it can be written in what's called condensed form. It can be written in what's called a condensed form. Now here's how you do that. Take your two inequalities. We have w less than or equal to 5 W greater than negative 8. And what I want you to do is find the one that has the smaller number in it. Smaller number is negative 8. So you're going to take W is greater than a negative 8, and what you're going to do is you're going to flip that. So instead of W greater than negative 8, you're going to write that as negative 8 is less than W. Now, what you'll notice is your W is sitting here, just waiting, and you know that W is less than or equal to 5, so there's that W. So all you have to do is attach the less than or equal to 5. So this is the condensed form of what we have written over here. Negative 8 is less than W, and W is less than or equal to 5. And what I like about this way of writing it is it kind of matches what I see on my number line over here. I have negative 8 right here, I have 5 right here, and where is W? W is here in the middle. W is that shaded stuff right there in the middle. So I like that it kind of matches up with that. So ORs give me airplane wings, and gives me a car bumper. All right, one last problem. So we have 28 is greater than negative 10m minus 2, which is greater than a negative 7. Now what I want you to notice here is that this one is written in that condensed form. And because it's written in the condensed form, that makes it an and inequality. So to solve this, one thing I could do is divide this up into its two separate problems. So problem 1 would be this. 28 is greater than negative 10m minus 2. And here would be my second problem. Negative 10m minus 2 is greater than or equal to negative 7. So when you get one like this that's already written in the condensed form, you can recognize that that is an and statement and split it into its two separate problems. And then solve that and finish it up. I'm going to show you, though, a way that will be a little bit easier for you. And to kind of help with this, I'm going to go back to drawing those lines in my problem through my inequality symbols. And what you'll notice is that that splits my problem into 3 parts. Now normally we say what we do to one side we have to do to the other when we're solving. Here the rule is going to be whatever you do to one part of it, you have to do to all 3. So my goal here is to solve for m. I want m to be alone. So if I'm going to get m by itself, the first thing I have to do is get negative 10m by itself. And I can see that minus 2 is hanging on in there, preventing that from happening. So to cancel that out, I would add 2. Now if I add it here in this middle section of the problem, I have to add it over here on the left, and I have to add it over here on the right. Now see, if I were solving this up here, I would have to add 2 to both sides. If I were solving this over here, I would have to add 2 to both sides. So I'm just getting it all done at one time. So these cancel each other out right here. So I have 30 is greater than negative 10m, which is greater than or equal to a negative 5. Now, to get m by itself, the next thing I need to do is cancel out that negative 10. So to do that, I'm going to divide by negative 10. If I do it in the middle, I have to do it on the left, and I have to do it on the right as well. Now notice what I'm dividing by. I'm dividing by a negative 10. So I have to flip inequality signs. So this will go from greater to less, and this will go from greater than or equal to less than or equal to. 30 divided by negative 10, negative 3. M is going to be alone right here, and then this is going to be a positive 1/2. So right there would be my solution already written in my condensed form. Now what does this say? This says that negative 3 has to be less than m. That means that m has to be greater than negative 3. And that m has to be less than or equal to 1/2. So there is the uncondensed form. All right, time to put this on a graph. M greater than negative 3, open circle, go right. Less than or equal to 1/2, closed circle, go left. This is going to be a car bumper because it's an and. For my interval, I only have to describe that line segment, which has endpoints at negative 3 and 1/2. Will be open at negative 3 and closed at 1/2. So if these problems are in condensed form, you've got two choices. Now, to kind of recap this, we started with our ors. We could have x is less than a, or x is greater than b. When we graph that, we're going to get the airplane wings. So open circle on A with shading going left, open circle on B, shading going to the right. Your interval notation is going to require some work because you've got two rays to describe. This ray, negative infinity to A, and then this ray, B to infinity. So you're going to do negative infinity A, B infinity. And it would be parentheses all the way around here with a U in the middle. This cannot be condensed. Then we come over here. You can have x is greater than A and x is less than B. That can be condensed. We take this and reverse it. Instead of x greater than A, we put A less than x. And then that will allow us here to just attach the x is less than B. Open circle on A, go right. Open circle on B, go left. That gives you that car bumper shape. And when you write your interval, you have your two values that describe the endpoints of your line segment. A, comma B, and here it would be parentheses for both. Now that probably is new to you, so should you have questions, please just let me know.